Hi, I'm Meta Spencer, and today we're really going places. We're going to go to the Arctic and we're going to the Andes glaciers. And boy, that's an adventure for me. And so anyway, we've got two women experts who are geographers who know a lot about the Arctic and other frozen, terrible places, and the leading expert on global sea ice in the world, Peter Watt. So let me start with Pia. Pia is Peter Adams's wife, but also is the president of the Society for Women Geographers. That's what it's called, and she already knows Uliana. Uliana Hurdiski. Am I pronouncing your name correctly?
Yes, and then the last component is Pena.
Pena. Okay, so your last name is Pena nowadays.
Officially, yes.
Okay, very good, Uliana. It's good to meet you both. Wonderful to meet you.
Me too.
Now, I'm going to add, I don't know much about you professionally, except I know where you've been, and that's of interest to me. But I'm going to ask you each to say a word or two about each other, because I know you've met, and how much you've worked together as women geographers is another matter, but at least you can say something. So, Pia, hi. How are you?
I was delighted to see Juliana that took part in the latest conference that we had with Polar Educators International, which is my other hat. This year I'm president of the Society of Women Geographers, but I've been president of Polar Educators International. Now I'm vice president. And it happened to be in Boulder, Colorado, and Juliana very kindly took part during our conference. So it was really having both connections was quite exciting. And also, I must say, having somebody so young and so brilliant and such a good scientist and such a wonderful woman geographer, I was so impressed because Juliana, by the age of 23, had been on the 7 continents, Arctic, Antarctic, and everything else in between. So it's a real privilege to know you, Juliana, and I look forward to knowing you even better in the future.
Thank you.
Oh, okay, Uliana, you tell us, who is this other lady?
Yeah, and so I met Pia just a couple of weeks ago through the Polar Educators International Conference, and the conference was just a week after I'd come back from the Andes, so it's kind of a whirlwind, and I'm like, yes, I'll find a chance to put a talk together, meet people. It was a great opportunity. So I'm just learning a lot about what the Society of Women Geographers does, and about Pia. And I was excited to find out that she participated in one of the first wintering scientific programs of a ship in the Antarctic. So just really keen to hear more about that. I think that was in the 80s, probably when I was born. And so just to see what a different world it must be now, it'd be really interesting to get your perspectives on changes as well, and to learn about, those. I love those kinds of, I don't want to call it old school, but I'm just saying more kind of nostalgic expeditions where the world was just completely different from what we have now.
Okay, well, I think probably your recent adventures are the things that we want to hear about. In particular, I think you and Peter have one obvious convergence of research, and that is Peter has already talked in some of the earlier forums that I've produced about the fact that the ice in the Arctic is getting black from soot. And that I'll let you describe why that's an important thing. But you reported, as I understand it, you finding the same thing on a big scale in maybe several different places. So since you have recently given a talk to the women geographers or whatever, the polar conference or something, why don't you kind of give us a snapshot of your whatever you told them?
Sure, yeah. So my research actually started in the Himalaya, looking at what are called supraglacial lakes, lakes that form on the surfaces of glaciers. And in the Himalaya, they're really dirty glaciers, but not in the soot sense, but in the sense of just a lot of rocks and debris on them. So why were these lakes forming? And I remember like one particular field season, I was trying to get to the glacier, and there was a huge dumping of snow. And I'm like, well, I can't get to the glacier. What am I going to do? And I'm like, well, I'm going to sample the snow, just see, because, there's a lot of local sources of pollution here with the burning of yak dung and kerosene, just in the villages. And so that kind of launched this new phase of my PhD, which was looking at particulates in the snow, and in particular, black carbon. So I kind of went with that as a last chapter of my PhD, and then since then I've been working a lot on these particles in the snow and ice. And basically, I mean, look at the shirt I'm wearing is dark. It's going to absorb more solar radiation, and so imagine there's all these dark particles on a white surface. They're going to absorb more of the sun's radiation, and melt faster. So basically, you're going to see this acceleration. And then this black carbon doesn't like the water, hydrophobic, and so it's going to keep gathering on the surface. So it's going to cause melting, right, of that snow and ice, but it's going to keep gathering, and then that makes this just over time, just in the span of just a few months in the Arctic, you can really turn that ice and snow dark, and continue to have this melting. And the thing about black carbon is it's a solvable, scalable problem. We know a lot of these sources are coming from industry. The biomass part from wildfires is harder, right? Because we don't have control over that. But at the same time, we can at least solve part of this problem. And that's what I've kind of been dedicating my professional career lately to researching and then trying to turn that into action.
Well, now you've just been to the Andes, right?
Yes, so that's an entirely different story. Are you familiar with the 1972 Alive story of the plane crash that happened?
Mm-hmm.
So for those who may be watching that don't know, so that was a plane crash that happened. An Uruguayan rugby team was flying to do a friendly match in Chile, and their plane crashed. And then there were 16 survivors out of the original 45 on the flight, and they were stuck in the Andes at altitude for 72 days. So it's just an incredible survival story. It's a really remote region. So where I was right before this Polar Educators conference was up there with my husband. He found the coat and wallet of one of the survivors about 20 years ago, because he went to see the memorial and check it out, and then was like, well, let me see where maybe up this gully the plane came down. As we started climbing up one of the gullies and realized, there's more things on the other side of a branch of another gully. And so we started going up there and saw something sticking out of the rock, some kind of like blue clothing. And as he unraveled it, there was an actual wallet and passport in there that said Eduardo Strach was one of the 16 survivors. So not only did he find, just a coat, wallet, all this stuff, but one of the 16 survivors. And they've been going back to the site for 20 years, and in the process taking all these amazing pictures to show the landscape changing. I've been joining since 2018 and putting my lens on it as a glaciologist. And what's striking is that this is, in a really remote place. You need to do a lot of driving, horseback riding, hiking, and actual climbing, to get to the impact point. So it's far removed from civilization, and yet it's dramatic, the changes that we see, the melting. So I brought equipment, to try to get an idea of how much loss there's been on that glacier. And it's pretty on par for global glacial loss. It's like 1 meter per year of loss. And we're talking about 1972 was not that long ago.
Hold on. Let me see if I get it. Are you saying that a meter of thick of ice per year?
Yes, vertical loss, actual vertical deflation of that glacier. Because the thing with mountain glaciers is they don't do like that retreat that we see on other glaciers that are entering the sea, like this clean ice that breaks off. It does this, it deflates. And so you can see the high marks for where the ice used to be. We have imagery from the 70s actually to show the height of that glacier that we can use as a baseline and see how much it's changed.
What happens is that the ice just evaporates. It doesn't run off as water, but it evaporates or what?
So we're talking about a very dry area. So it's a mixture of, there's a lot of melting. You'll hear it. You'll hear a lot of the water just flowing, and possibly some sublimation, just because it's so dry. And so it'll go
Excuse
from
me,
that.
I don't know that word. I
It'll
know
go
what it means in psychology, but I don't know what you mean.
and going from that solid phase of ice directly to the vapor, to water vapor. But we do also see just a lot of melting. I mean, in the time I've been there, over the last 7 years, it's incredible just how much more exaggerated that melt is. Just really like rapid melting.
You see an acceleration.
Yes, and comparing it with my husband's photos from the early 2000s, it's pretty drastic. I mean, you could see like a proper glacier before with crevasses, these cracks that form in the ice. And now when you go, there's just all these rocks on top of the ice, and some cracks, really big melt channels. So it's
Sorry, but where do the rocks come from? Are they falling off onto the ice or what?
exactly, yeah. So imagine it's this mountain surrounded by other mountains with the glacier. So yeah, as the ground also thaws, that's also dropping a lot of the rocks, yes, onto the glacier.
Tell me a little about what you found several months ago. I believe you were in the Arctic.
Yeah, so I recently came back from an expedition to the Gulf of St. Lawrence in Canada and the northeastern part, because I was actually really curious about the state of that river ice that's changing and melting in a historically polluted area. But last summer, I had a chance to go to Greenland, and I was very curious to see the state of the sea ice changing. So I'd love to hear from Peter about his observations. But it was early season in June, and the ice was already very dark. So I sampled it and I had a look at it. It's a mixture of things. There's a mixture of black carbon you can see in it, and also dust that might be coming, from the surrounding mountains that are coming off from the coast. But I was just impressed at how quickly that ice had already darkened. And I would also love to hear from Peter about the state of the Arctic sea ice, because it should have reached its maximum extent. And I'm very curious to hear, like, what does that status look like, and what does that mean for the next few months, really, because we know, much like those dark particles that fall on the ice, once you start to melt that ice, you reveal the darker water below, and that has that same impact. It will heat more, it'll absorb more of that solar radiation instead of reflecting it back. So now we have this whole process set in motion.
Where's this water? On top of the ice or on? I've heard of, I'm thinking of Antarctica where the problem is the water is under the ice. But now are you talking about water on top of the ice or what?
I'm talking about the sea ice, so the frozen ocean. And so up in the Arctic, right, we have the Arctic Ocean surrounded by land. So we have all this sea ice, the frozen ocean, that it's melting because of increasing ocean temperatures from below and from the air temperatures just from above, if you will. And then when you add pollution or this black carbon on top of that, now you have a three-pronged attack, if you will, on the sea ice that's causing it to melt. So what I mean is, we do actually see little pools of water form on the sea ice in the Arctic because, this pollution might gather and cause extra melting. So it's a complex problem, but it's a simple concept as far as how it's melting. So yeah, I would be very keen to hear from Peter about his observations, because my impression is that this is also accelerating, similar to how alpine glaciers are melting.
Well, I agree. It's very much similar in the Greenland glaciers are very similar to the behaviour of the ice elsewhere in Chile. Firstly, this is the lowest level, or the most retreat of sea ice that's occurred ever, and we're also getting the most extreme high temperatures. So all the trends are going towards warming. The what Jana said about the sea ice is very similar to what we see in the Arctic. I was collecting samples of ice through a winter, and
Sorry, from Greenland?
from Greenland, yes, and there's a lot of interesting things about this stuff, which you when you look under it under a microscope, it's not what it's not what I used to, and sort of I'm always used to huge lumps of ice, and there's these tiny samples, but they include a lot of sort of fiber, some sort of fibrous shapes, and
Polyester as well, yeah. Bits of polyester that get onto the Arctic ice.
Yes, it must be.
Polyester, you mean like the stuff
Yeah, like from your clothes, yeah.
Really?
And that was found when Peter was at the Politecnico in Turin, and he gathered these samples because it was actually a race, extreme race with electric SUVs. And Extreme E had in 2021 a race on the glacier, and their legacy project was to gather samples that were then analyzed at the Polytechnic of Turin. In fact, a paper that Peter has written with the experts in Turin has just come out. I'd like to send it to you, Juliana, because
That'd be great.
it's interesting. Because I was there when one of these experts, these professors, she was looking through a microscope, and that's when it's amazing the little bits of fabric, and she could because she got an enormous practice, she could detect which was polyester, which was cotton, because they behave in a different way.
It's remarkable the amount of ice that's gathered from the ice, the melting of the ice underneath leaves this stuff on the surface.
Now, it was about 2 years or 3 years ago that you were in Greenland. When was it?
2021, yeah, about 4 years ago.
3
Yeah.
years ago.
You know, it's interesting that you mentioned all these threads because I was finding similar in some of the Greenland samples I've been looking at under the microscope, and just got a small grant to be looking at both the impacts of black carbon and microplastics in this snow, because I think that's such an unknown about, well, what impact does that have on melting? It absorbs light as well, but I don't think it's really well quantified yet. So I'm very excited to be working on that and being like, well, what? It's unbelievable to have found so much, and it's coming from us, from long distances, or even maybe locally from ships. So there's just so much, so many of these, I call them persistent pollutants in the environment.
Yes, it's like sort of blotting paper, symbolizing all the gunky things and horrible stuff that's floating around in the atmosphere, and that is polluting the world, is gathering in the Arctic.
Yeah, but that's the idea, that it's such a pristine world. People from the outside have no idea how polluted the Arctic has become.
Right. And that's why we tell people, don't eat the snow. That's how I start a lecture. Like, beyond the obvious reason, let's actually look at. And then when they see, like when I was on this recent expedition in Canada, oh my God, there's so many threads in the samples. And they were looking at it under the microscope. They're like, yeah, this is why we don't, because like you just said, Pia, like it looks pristine. And one of my first, before my project turned into persistent pollutants, it was pollution in pristine places. I love alliteration. So, but it's true though. These places look pristine, and people assume, like in West Antarctica, where I was able to go last year in the Ross Sea area, same thing, much cleaner than anything else I've seen, but still present. So it's still present. You can still see little threads. You can still see black carbon.
Which area of
Here, I mean, this bothers me in another sense. That is, I have friends who are still trying to say, well, we just need to do more to clean up the world and try to live simply and not do this or that, and don't pollute and try not to consume too much and all that. But I mean, you can give a case for how you might be able to reduce the amount of black carbon falling on the ice given 100 years. but I don't see how you're going to say people are going to have to stop wearing clothes. I mean, people, what's the cure for a problem like that? Isn't it just inevitable that the that these fibers are going to show up in the ice? And why didn't it happen all along, by the way? I'm asking
It
that.
didn't happen in the past because we didn't have microscopes. We weren't able to look at this and think, gosh, what's this kind of stuff?
Also, there were less people in this world wearing clothes. You know, we were not as many 100 years ago. And, but, you know, maybe what Peter says as a kind of joke, it is true that, you know, you didn't know what was going on. But
I mean, yeah, it's a tough question. And to just answer you, Pia, from earlier, the Ross Sea area in West Antarctic is where we were looking. So like 78 degrees south is as far south as we made it by ship, and we still see fibers and black carbon. But I remember when I was a teenager, and I love those exfoliating scrubs, right, for washing. And those are these little micro beads that have been kind of phased out when it was realized, well, that's damaging the environment. So Meta, you can get rid of some of these things, right? Kind of change the regulation for cosmetics and cleaning products. Biodegradable materials. What if we made our clothing more biodegradable, but not obviously during the lifespan of us wearing it?
I was standing there giving a speech, and oops, there was a day for my clothing to disappear.
But you know, like when we look at our dryers, right, the filters trap a lot. It's incredible. Like I make like a felt carpet when just washing sheets. I couldn't believe how many fibers were caught there. But yeah, I mean, it's a tough question, but something we have to address because, or you know, it's a plastic world also to an extent. We have phased out the plastic bags at our grocery store here in Colorado only recently. It's insane because we've known about it for so long, why it took so long to change laws. But I think that's where education really plays a role. I think if you also come at it from a human health perspective of, do you know that you consume a credit card's worth of microplastic every year and what effect that's having? They're finding effects in the brain and in the heart now from these microplastics. So I think reframing it in the human health capacity can help get the message across. And the same thing for black carbon. It's pollutants that can also affect how we breathe. Right? So it affects our lungs, it affects our cardiovascular system. And that's why I found like to reach more audiences is not just about the health of the ice, which I love talking about and that's my passion to understand, but relating it back to the human story is also really important.
Okay, but let me explore this a bit because you know I'm hearing a contrary story, and that is from people who have been disturbed by the increase in global temperature very recently, very rapidly. It was a spike that nobody could explain, and it seems to have been the result of a ruling by some kind of International Maritime Association, or I don't know the title exactly, but it's the organization that governs global shipping. Mm-hmm. And what they did was say that all the ships in the world have to stop using bunker fuel, which contains some kind of, I don't know what all, sulfur and other bad things, very polluting and very damaging, and use some better, cleaner type of fuel. Well, as a result of that has actually created a spike in global temperature because the emissions, the nasty, unpleasant, regrettable, polluting emissions from those ships actually created kind of tracks or what looked like clouds and functioned like clouds over the ocean. And those little white streaks of cloud have albedo, you know, in that they reflect light back out of the earth. And it was enough of the extreme the emissions that were being shunted off, reflected back into space, that helped to keep the planet cool. So when they stopped that, it warmed the planet.
Yes.
Now, it could be that the some of this soot that you're getting on your ice in the Arctic or in the Andes and the Himalayas come from ships as well. So you've got this double-edged sword, this trade-off. Which do you want to get rid of more, the pollution or the global warming?
Right, but there's an important distinction here. So there's two types of particulates. If you want to just to simplify, there's the ones you're talking about, and the regulations that were put in place was to get rid of sulfates. So sulfates are known to reflect solar radiation and cool. Black carbon is still present in a lot of these heavy fuel oils that are used, and that actually causes the warming. So yes, we unfortunately by cleaning things up with the sulfates got rid of the cooling effect, but that just means the spike that you're seeing, that's the black carbon component, right? So that's still causing the warming. So if we can fix that problem now, it really shone a light on black carbon being a problem. So now we know that that's the problem. We can clean it up. That's going to improve. So yeah, it's I've gotten this question a couple times now, exactly to what you're saying about, well, wait, we got rid of this, we cleaned it up, but we had a spike. And it's exactly because there's two different kinds of particles at play here. The sulfates that reflect and the black carbon that warms. And black carbon is just like second to like carbon dioxide as far as like warming potential. It's shorter lived, right? So you can clean it up, but it's pretty potent. And if we can do something about it, we will definitely put a dent, if you will, in that spike. I don't know if Peter or Pia wanted to say anything further on that.
Yeah.
Well, yeah. I mean, it's true, and the odd thing is that you take a glacier, and it's like the sort of blotting paper effect. You're seeing everything that's been deposited on that glacier, and the extraordinary thing is how much there is, and the variety of material there is there, and of course that's falling out all over the world, including not just
on the ice,
glaciers, but also on surfaces generally.
Well, in the cities, I mean, you can't breathe in the cities. You have the particles.
Yeah.
I mean, I come from Milan, and Milan usually has a fairly bad air. Not terrible, because it's done quite a few things to clean up the air with, using electric buses or hydrogen public transport. But, we still have the spikes of particles where we are told, don't go out.
Right.
You don't suspect the variety and amount of gunk that is going over the surface. For instance, where I've been living in Turin, there's an incredible amount, and in fact, what we think it is the trams, the brake shoes of the trams, producing a lot of
black carbon, plastic
particles, particles, and so we're living with self-inflicted wounds here. With
But I was really frightened when somebody said, and you are confirming it, Juliana, that even in our bloodstream now we find microplastics.
Right, that was disturbing, and there was some new research. They couldn't exactly tie a heart attack to it, but they found micro and nanoplastics present in the blood vessels. So they were like, wow, this is a first. So yeah, this is a very hot topic for research right now about what the impacts are in the human body. And again, I think like if we're focusing efforts of education, coming at it from that perspective where it affects everyone, sometimes works better than talking about ice, which we all love here, but it's far more removed. But what happens in the Arctic doesn't stay in the Arctic either. It has global ramifications, but it's sometimes harder for people to make that connection.
Well, I think we need to focus. I've been trying to do my part to draw public attention to the global warming aspect of the well, the fact that the albedo explanation for global warming is really about as important. As I understand it, you can tell me whether I'm right or wrong. I've read this, that if you quantify the effect of carbon emissions from fossil fuels versus other kinds of albedo effects on the amount of heating of the planet, that the albedo effect, all told, would equal the amount of impact that is being exerted by the CO2 emissions or the carbon emissions, which is the only thing that most climatologists still are working on. I think if you talk about the IPCC reports and the COP report, events and so on, they really only focus still on carbon emissions, trying to reduce that, but they aren't focusing adequately on the impact of albedo, that is the reflectivity from either ice or clouds and so on. Now, did I make that up? I don't think I quite made it up, but I sure could give you a reference to where I heard that. Is there any validity to what I just said, or am I imagining things? Do any of you know?
No, I think those figures are pretty much correct. Yeah.
There's go ahead.
Go ahead.
I was just going to say, so when it comes to CO2 emissions, the reason there's been so much focus on that is because of its long-lived potential in the atmosphere, right? So if we were the pandemic is a great example when the world shut down, and then how much impact that it actually have. Yeah, Pia, very minimal. So it's like, exactly. Oh my goodness, this is a bigger problem than we thought. This is going to take
expecting a little blip, just a little blip from the Mauna Loa records. And it was nothing.
Yeah, and that was disturbing to me because I'm like, oh my gosh, so what do we do about this? So that's why I've kind of been focusing more on black carbon. This is more of a manageable problem. It's a short-lived pollutant in comparison, like a couple of weeks versus centuries for carbon dioxide. And so it'd be interesting to see if we can move the needle, on global warming, if we can take care of at least that component. And by taking care of that component, the black carbon, you also address the albedo impact, Meta. So I think it has
That's a very good idea and great. I think it'd be great if this can be done, because we've really got the possibility of analyzing this stuff now, and so we can really see what the proportions are, what the fractions are, what are the things that are doing the job, and so we've got all the things we need to do an analysis of.
Yeah. Well, the other thing that Peter is very much involved is the methane, and methane is now coming up so much more because of melting the permafrost in the Arctic. And, you just get the feeling, one runs a bit, but what comes is a flood.
Yeah, they're linked in some way. I mean, to some extent, the amount of methane being produced from the Arctic is related to the fact that you've got a lot of melt going on, and the melt is affecting both the ice that's melting and then the
land.
The land surface, which is this messy material of surface melt. So we're seeing the impact of the ice, of the meltwater, at the same time as we're seeing the impact of the ice. So it's
the methane is a very important point, because from what I understand about it, it's very potent. I'm not sure how many times stronger it is than carbon dioxide, 80 to 100. Is that right, Peter?
It's about it varies from time, about 30.
Okay.
it's 30 to 100. It's weird.
Okay, that's the range.
It's a weird
Yeah.
number,
And
yeah.
like it's also shorter, right, on the decade time scale than carbon dioxide, but longer than the black carbon. But yeah, the important thing from that is just the potency of it, and there's a lot of it trapped also up in the Arctic in the permafrost on land, but also under the water in the ocean.
That's Peter's bag. He's a real expert on that. And he's scaring everybody. At least I hope. People don't get scared enough. They should be more scared, because every time Peter gives us talk, it scares the daylights out of me about the possibility of huge emissions, because the quantity of I don't know, you want to tell them about that, Peter, because the quantity of methane under the ice that could be released in big gushes is so stupendous that I should.
Well, it's frightening, actually, yes, because you've got processes going on which are releasing methane from under the water, and that can, if you get a warming going on, the methane emissions will suddenly go up, and then you've got something which is causing major impacts. And so we've studied methane emissions from melt of ice with Russian colleagues, and
The East Siberian Sea.
in the Siberian Sea. But it is kind of frightening what's happening.
Yeah.
That's what I saw one time. And I wish I'd kept a reference to it, because I've told people about it. Now I can't find it. It was a video somebody made on a ship going through, I think, the Laptev Sea, someplace Siberian waters. And it was at a time when there was methane coming up in bursts from the ice, or from the, I don't know whether it was just open water. Doesn't matter, because the point is, it was like being on a plane going through clouds, all this white stuff around you. And it looked the same, except that every now and then you could see a little burst. You don't see that in a real cloud, but a little burst, a plume of of methane being ejected up ahead of you and then dispersing. But it was really amazing to see the quantity. I think if you lit a match, the whole cloud might have burst into flames. I don't know.
It would, yes.
Yeah, like in the documentary that was supported by Leonardo DiCaprio, called Ice on Fire, and Peter is in that as well. We went to Cannes when they showed it the first time. Peter went on the red carpet in Cannes.
Nice. I'm going to show that in my class. I have a class coming up now on Intro to Climate Change. Right. I'll show it.
It's a good film, yeah.
Yeah, it is very nice. And when they actually have the methane coming out from the lake, they just pierce the ice, and then you get these flames coming up. And that is, as polar educators, that's amazing.
I was going to say that visual is so powerful. And I found that in my work as well. It's like you can show all the graphs you want, but you show pictures of the change. And that speaks to people about like, wow, that's dramatic. And then you tell them, oh, that was just 50 years. Right. So there's a lot of power in that imagery we can use as educators.
The trouble is when they ask you, what can we do?
Right. Right. But I think that's what I've been thinking about that a lot, because with this class I'm teaching, I'm presenting the problem of climate change and the science behind it to give a strong foundation. But I also want it to be solutions oriented. So take a problem, take a creative lens on it and see what could be some of these, even the wacky solutions out there. It's one of the interesting things maybe Pia or Peter know about in Iceland. They've had success of creating carbonates that they're putting in the volcanic rock to try to sequester carbon dioxide that way. That's super unique, and they've actually taken it from theory to practice now. And so you never know. So I'm trying to also encourage students about this kind of innovative, outside the box thinking.
Well, Climeworks it's the one where you can actually have a visiting center. But we went to visit various carbon plants that were trying to get carbon out of the atmosphere in California. And we actually have somewhere in the house the little balls that were in fact carbon neutral, and they made sand out of carbon, so the sand where carbon has been CO2 has been completely taken out. And they did it was used for the second terminal in San Francisco Airport.
Well,
Is
That's,
Blue Planet
yeah, Blue Planet, exactly. Yep, that was the one we visited.
I keep
But
trying to promote that, and my friends keep sort of watering down the message by talking about low carbon concrete. Low carbon concrete, it's all well and good, but we're talking about something extraordinary. If you actually are able to, in a way, extract CO2 from the atmosphere and make it carbon negative so that it actually helps grab and allow you to sequester carbon, that's a different ball game.
mhm.
And it should be focused on, the attention should be focused on promoting carbon negative concrete.
Right.
Low carbon is all well and good, but this other thing, what Pia is talking about, I think is extraordinary and should be really focused. I mean, we should be trying to promote that big time, don't you think?
yeah, the problem about the more recent studies is how much energy is being used that produces pollution and CO2 in order to have this plant that takes the CO2 out of the atmosphere. And that is a kind of balance. And again, Iceland is very good because they have so much hydropower.
Mhm.
And but other parts of the world will have to get the energy from electricity or and you
And
know
it's and also it looks bad, worse, getting worse because of the explosions that are going and the underground explosions where you're having big methane explosions and it looks like a crater.
oh yeah.
And these are all over the Arctic, so it doesn't look as if we're winning the battle against
Yeah, I mean, those
against
craters are unbelievable, actually.
the,
Is if the focus is on black ice, black soot, on soot, what are your priorities for what could be done to cut down those emissions? Because I mean, maybe if we talk all the time about fossil fuel emissions, but that's very general, very wide, and certainly we're not succeeding with that. But it might be that there are certain kinds of soot that we could cut back on that would make a difference. Do you have a priority about what the sources are that should be noted first?
Yeah, a big one I've been focusing on is shipping, just because I've had just so much more experience, up in the polar regions, and then just researching just how much impact shipping has. And if we switch fuel sources, we can get rid of a lot of that. Like there's already regulation that cut down on the sulfates, right, which cause unfortunately the warming because now black carbon's taken its place. So I think the focus really should be on the shipping industry, because I don't know if you've ever seen how many ships are out globally on a daily basis. It's incredible.
Yeah.
And if you just do a simple calculation about how much black carbon is being emitted, I mean, we can really make a dent on it. So that's my target. I'm trying to apply for another grant to be looking at turning the data we've been collecting into actual action or policy. I know in Europe, at least, that they're trying with regulations in the next couple of years to try to enforce either a fuel transition and eventually going to zero emissions. But you can't really make that jump to zero emissions immediately. It's really hard. So transition fuels like liquefied natural gas, for example, I know that's the methane problem, Peter, but it's at least a step in one direction to get rid of black carbon. But then we have to be thinking about those impacts as well. I'm not advocating for switching everything to that fuel source, and I'd love to hear more if Peter. But yeah, I'm kind of looking more towards shipping right now personally.
Within the past 2 weeks, I believe, my memory is that things have come through my email celebrating because this Maritime Association did some new measure some new regulation of some kind that people were very happy about. And I was confused because I thought it had something to do with this in a way you can say kind of mistake they made about ruling out bunker fuel. But they did something that everybody's happy about, and I don't quite understand what it is. Is that related to what you're proposing?
Yes, it may be. I'd have to look up to see exactly what you're referencing as far as the regulations. But yes, there's meetings being held, I think even right now, and into 2026, with maritime associations to try to reduce black carbon. And so I think it's going to take like 4 to 5 years to make those transitions, just because it's quite costly also, and changes to infrastructure. But yeah, Peter or Pia, if you know anything further on that front.
I know that see there's a lot of shipping around that the website
there's an app called Marine Traffic.
Marine Traffic
It's
is
frightening.
the
number of ships in the world.
They mainly show it these days when they're dealing with the Panama Canal. But it shows every ship that's in service, and it's pretty frightening and to see how much there is.
If I can switch conversation just a little bit, and because I have this is an opportunity to question you about a social life in the Arctic, I think, Pia, as I understand it, a lot of your work, your research has to do with people living in polar regions, and I don't know. I have to admit, I don't know your research, but one of the things I'm always trying to do is make contact with indigenous people who are affected by climate change, either in the Arctic or for example, the Australian people living near the Great Barrier Reef, or maybe even people in the Andes. I don't know. I haven't thought about them, but indigenous people, because when we do these conversations, we ought to include the people who are living in the area that we're talking about. And I find it quite difficult to be in contact with people who are willing or able to make such comments. Are you both, are all three of you, in touch with communities of people that I might get in touch with you and ask for phone numbers or email addresses of people that I might be able to do? Yes, Pia, can you? Is your work relevant to what I've just been saying?
Especially with polar educators. Polar Educators International was actually founded about 12 years ago as a result of the last International Polar Year. The last International Polar Year was, which was 2007 to 2009, was for the first time actually producing lots of interest about education. It was spearheaded by one of the organizers who really thought, if we want to really make people understand the importance of the Arctic, the Antarctic, the polar regions, we must educate people. We must have this knowledge of these places, which are not all that far away, and as you know, what happens in the Arctic affects the whole world. So in fact, one of the results was a wonderful book called, we call it the Polar Resource Book, and I'm in charge of getting a new updated edition with other partners. We are unfortunately at fundraising level, which is always the problem. But we are very much modifying our point, which is not just having educators, teachers, educators to talk about or what happens in the Arctic, but involving people who live in the Arctic. And this has been, in fact, in this latest conference in Boulder, Colorado, where Liana spoke, and it lasted about 9 days in all, and it was actually one of the meetings was ICARP, which is the International Committee for Research, Arctic Research Planning, and I'm in the steering committee for education in that. And it defined the research in the following 10 years. So we are doing it between 25 and 35, and it will cover also the next polar year, which is going to be in 32, 33. And also, we, with Polar Educators, we started what we call the global conversation, which is really like a world cafe. And we try always to have indigenous people coming. But you know what is the problem is now that indigenous people are recognized as a big factor and also a very good source of information, and also to be involved with the scientists in the Arctic, because they know their region so much better than the scientists coming from the outside.
These are great points, Pia, and I love the work that you're doing in that realm. Like in my PhD work, I built the Sherpa Scientist Initiative back in 2011. As a graduate student, and I didn't have money to continue it, but it was the same idea of like really working with communities in the communities through participatory science, and I've kind of carried that through in my career. And like I'm really keen to be doing that, especially with like Arctic monitoring. Like we need a lot of data really to show the impacts, for example, of shipping on the ice. And something I was actually a co-author on a publication called Advancing Justice-Centered Community Science. And so it was all about, well, if we want to work with these communities, what are the strategies to do it, right? How do we actually work with them, not just come in and say, here's what we're going to do. All right, so that's also very important for us as scientists and communicators, is really working within that community, hearing from the community, and listening. So,
yeah. And they really are very interested in collaborating, especially the high school young.
Really?
Yeah, absolutely. The Inuit, especially in Canada, that we know it's Canada, Greenland, and Alaska, the young people actually are getting, high school education, and they're not. They're working really hard. They go to school, they go to university, and then they go back in the community. But what was interesting, because I've been following Peter for the last almost 50 years of our lives, what was interesting was all the proposals that Peter was writing in his 20s, 30s, etc. It was absolute pure science, and also for the European Union. And then they started in the European Union that unless you had a social science program in your proposal, it wouldn't get funded.
mm-hmm.
And that was when Peter was, they actually put a radar on wooden dog sledges in a village in northern Greenland because the ice was melting, and they were losing dogs and people in the ice. So having the radar, it would tell them how thick the ice was. And so it made safe. So, that was a positive collaboration.
Yeah, the community aspects of it are so wonderful here.
Yeah, there's a long way to go because also, like you said, Meta, let's get people, like we like to have people for our global conversation. But, the native people are a limited number, and they have their own things to do, like hunting walrus and feed themselves,
Fending off the Americans.
Yeah, and that's it's difficult also to get them because they can't spend all their time as they're wanted to talk about it. So it's a difficult balance for them as well.
Well, but I mean, do they have access to even to do a cell phone Zoom? Because that works fine if they have it, but I don't have. I just can't make the kinds of contacts I need. And also, I think there are Sami people in Scandinavia who I'm in. Some of the young people I've met from some of the Scandinavian peace organizations are very interested in technologies that would actually help cool the Arctic. And I think that is not the case for all Indigenous people. There's some of the contacts that I had with Indigenous leaders here in Canada, they kind of shake their heads in dismay because the elders may have a more fatalistic attitude toward global warming and just not be ready to do anything that Peter or you would advocate, or I would advocate in terms of technologies for maybe reversing things. But at any rate, I want to get your advice, and maybe we can collaborate on hosting several different shows where you invite your friends and talk to them, and I just sit back and listen.
That would be very, very, very good. Thank you for the opportunity. It can be difficult sometimes for them to connect. Like we had a wonderful Inuit woman that through the Scott Polar Research Institute in Cambridge, I was introduced to her, and she would have made a huge contribution. And on the morning, on the Sunday in Boulder, just couldn't get through.
Yeah, I was sad to have missed that. I mean, there were some Indigenous people there, and it was wonderful to hear from them. They had great questions, and yeah. But that was a shame because with the connection. But yeah, like you're saying, like there's just so much importance. There's so much history. There's so much, so many stories waiting to be told, and that's why as scientists coming from that lens of listening is important as well. So we really learn about how that landscape's changing, and then we can bring in like the technology. Hearing about you with the radar on the dog sled, and it's helping a community as well through technology and using it in a way for good, right? Because technology is a double-edged sword as well. So.
Well, now, the population of Greenland is apparently largely Inuit. I didn't even know that until recently. I don't know who I thought they were. They're Inuit. And obviously, nowadays, they're very politically organized and exercised about this threat to their autonomy. I mean, Trump has said that he will take Greenland because he needs it and he's going to have it one way or another. By God, that's really an ominous thing. I don't know whether, clearly there's a lot going on there in terms of discussion about their own future. But I don't know how that impacts on the global warming issues, decisions about how to policy about what to do in terms of technology.
Well, they are. It's interesting how a threat like the one that came recently is focusing people on what really counts. Because for a very long time, the people in Greenland wanted to get rid of the Danish influence and the Danish colonization, if you like, to the point that now it's largely autonomous, but its defense and I think health is kept by Denmark or is managed by Denmark. And they were kind of wanting to get this freedom, etc. But when you come to be threatened, like they've been politically threatened, it focused them on what is really important. And Denmark didn't seem to be all that bad after all.
Right. Yeah, that's an interesting perspective.
There has been a kind of shift because they were having elections, in fact. And a bit like what's happening in Canada, I guess, in that you focus. Then the party that you elect is the one that is more what people really want, and people really want was autonomy. But in a way, having Denmark, which is part of the EU, which is part of NATO, is actually not such a bad thing for the people in Greenland right now.
Yeah, I mean, it's a good point because what would happen with all the mining and all the new ships coming, and we would exacerbate global warming actually. And then there's the indirect impacts of what are those minerals being used for? What are we building? We're polluting. So.
Well, actually, Meta could be making a talk like this with one of our dearest friends who's a retired Coast Guard from the US. It's called Lawson Brigham, and he's actually done a PhD in Scott Polar under Peter. So Peter was his supervisor, and he's a real expert on Arctic marine traffic and shipping, etc. In fact, he's giving a lecture to another group.
Good deal. You put me in touch and we'll have.
Yes, I think that Lawson could be a marvelous, would give you a lot of ideas because he's also, in the past anyway, was very connected with the Russian Arctic as well. And so he was really giving this global view, which was very, very interesting. So.
Okay, well, I will definitely pursue this. Ideally, what I'd like to do is bring in some people from different areas. Cree, for example, many of them live in there. And the Scandinavians. Well, it'd be interesting to hear them talk to each other about what they want to do. I look forward to more conversations like this.
Yeah. Thank you so much for bringing us together.
Thank you.
Bye.
Thank you.